Welcome to our third Wise SCADA lesson. In this lesson, we continue with the SCADA tag configuration topic, which is a continuation of the second lesson. Now, we will examine how the bits of tags read from the PLC are used within SCADA. We can read bits directly from the PLC. As seen here, Boolean type variables are read as bits in the form of true-false. But the topic we will examine now is the use of bits of a number read as a byte or 32 bits within SCADA. We are writing to an area not used before within the PLC. Marker byte 200 is an 8-bit variable. Let's add a new device under the internal tag protocol. Let's create two tags of Boolean type under this device. We are copying the symbol of the tag here, that is, the tag we read from the PLC. We paste it into the address section of the first tag and write the bit number inside the bit parenthesis. We wrote the first bit for the second tag as well. We need runtime to continue this test. We are adding a text box. In the values section, we use the variable named tag4read from the PLC. We are adding two checkboxes. For the values section of these objects, we selected tag 5 and tag 6 where we will show the bit values. Now we are running runtime. We are sending a set value to the PLC. When we write 1, the first checkbox became checked. Meaning, the 0th bit became 1. If we write 2, the first bit becomes 1. If we write 3, both bits become 1. Likewise, when we change the bit values, you can see that the number in the PLC changes. Another topic is that although generally not in PLCs, devices like energy analyzers may use the number as 100 times its value instead of using decimal numbers. For example, an energy analyzer may show the voltage value as 22,001 or 22,002, which is 100 times its value, instead of showing it as 220.01. Let's examine how we will read this within SCADA. We are adding a variable. Let's call its address MD400. And we copied the symbol again. Now we are adding an internal tag. We are changing its type to decimal number real. In the address section, we write the tag we read from the PLC in 100 with the div parenthesis. Meaning, we will monitor the version of the tag read from the PLC divided by 100 in tag 8. We are adding two text boxes for this. Let's add one for SCADA as well. Here, we selected tag 7 read from the PLC in the values section. In the other one, we selected tag 8 where we will read its version divided by 100 as internal. We ran runtime. Let the value we read from the PLC be 22,001. We saw it as 220.01, its version divided by 100 within SCADA. Likewise, when we change it from the SCADA side, 100 times this will be written to the PLC. There is also the reverse of this operation. We can use the mul parenthesis to multiply instead of divide. Let's try again in runtime. This time, we will see 100 times the value read from the PLC. Likewise, if we write a value from here, we will read its version divided by 100 in the PLC. We have a slightly more complicated structure, that is scale. Let's have you examine its formula before defining scale. You can see it right here. There is a standard linearization formula here. Now let's define scale in the code section. The first value of the scale parenthesis is the minimum value of the read value. Let's determine the second value, the maximum of the read value, as 1000. It should be noted that parameters must be separated by semicolons, not commas. Let's define our output value as 0 and 10 and close the parenthesis. This will basically be the version of the value coming from the PLC divided by 100. Let's try it immediately. When 22,050 comes from the PLC, we see it as 220.5. Likewise, when we change the set value from here, this value is written to the PLC as 100 times itself. Of course, scale is not used for such a simple purpose. It can be a slightly different structure. For example, let our input be 0 and 1000 again. But let's assume our output value is 10 and 20. In this case, when we read 0 from the PLC, we will see 10. When it is 1000, we will see 20. When it is 500, we need to see 15, which is between 10 and 20. Likewise, the reverse operation is possible here as well. We have come to the end of this lesson too. Thank you for watching.